All right, AND gate, again, it starts with 5 volt potential difference. It has 2 input, as you see over here. It has 2 input, one from 5 volt, one from 0 volt, and it has 1 output. Okay, it looks like shape D, like letter D. Actually, it looks like letter D. When you connect it AND gate to the 5 volt potential difference, it's going to start working. So we are going to learn about truth gates, truth table. What does truth table mean? It means whether transformer, whether the logic gate works or not, whether like conduction happens or not. If input A is 0, that means it's off. Input B is 0, that means it's off. Okay, when you see 0 0, it means both of them are off. It means there is no like flow of electrons or flow of current. Okay, so the output will be also 0. Okay, so the output 0, that means output, there is not going to be flow of current in the output as well. If like the part the logic gate A is 0 and B is 1, that means B is on. There is current flow here, but there is not current flow over here. In the AND gate, we're not going to see an output current. Okay, there is not going to be output current. When you change the places, like when the A is 1 and B is 0, and terminal A is 1 and terminal B is 0, then again there is not going to be any current flow in the output. It's going to be 0. Only there is one possible current flow in the output when both A and B, both terminals A and B are 1. If they are, both of them are 1, then there is going to be current flow in the output. Okay, if both of them are like 1, and there is going to be an output flow. So how are you going to guys remember this? Let's say when I say, like, for example, when I say my name is Isa and I wear a hat, the both two statements are correct, so both of them are true, so the output also is going to be true. Okay, but when I say my name is Isa and I am wearing like a black suit, yeah, my name is Isa is correct, but I'm not wearing the black suit, it is going to be false. So 0, let's say we call 1 is true and 0 is false, so at the end the statement will be false because I'm not wearing a suit. Okay, same thing. This is how you are going to identify. Both statements must be correct in order to get a correct output. Okay, you are going to remember AND gate like this. So both terminal must connect to, there is going to be electric current flow in the both terminals A and B. So there is going to be output current. Let's go to the OR gate. OR gate is like vice versa of the AND gate. For the OR gate, like we can say here the truth table. Let's go over here. The OR gate looks like a like spaceship. Okay, it looks like a spaceship. It has 2 again input, 1 output over here. So it behaves like 2 switches in parallel circuit. Okay, 2 switches in parallel circuit. We can say AND gate works like 2 switches in series circuit. So for the OR gate, if both of them are 0, like if there is no current flow in the both part, then it's going to be 0, the output current. Okay, but if one of them, even if one of them, like there is current flow in like A over here, let's say in B over here, if there is current flow, that means there is going to be current flow in the output as well. Okay, if there is current flow only in A, again there is going to be current flow in output as well. Okay, it is going to come like this. If there is current flow in both of them, like here and here, both of them, then the current flow is going to happen at the output too. So OR gate, just one statement, like let's say my name is Isa, or I don't like physics. Yeah, my name is Isa is correct, but I don't like physics. That statement is wrong. So the first part is true, the second part is false. Okay, the second part of the statement. But at the end, since one of my statement is correct, at the end we are going to have a true statement over there. So the output voltage, you are going to remember like this: if one of the like terminal have the electric current, then output current, we are going to see the output current there. Okay. If only both of them are wrong, like both statements are not correct, then we are not going to have any output current for the OR gates. Okay. So we're gonna have question at the end about, like, we are going to have combination of the questions about these gates. So there you will understand hopefully better. Let's continue to do NOT gate. NOT gate means like if if there is output current, there is input current, there is not going to be output current. Okay, NOT gate, it looks like a triangle. As you see, there is a hole, small hole at the end of it. So NOT gate means if it has only two terminals, one input, one output. Okay, if there is input current, there is not going to be output current. If there is output current, there is not going to be input current. Okay, so let's say if there is current over here, it is not going to go to output, it's going to stop. If there is current at the output, it's not going to go to input. Okay, it's going to stop. So when A is 0, the output will be 1. When A is 1, the output will be 0. Not means this. Okay, if 0, then what is the opposite of 0? 1. If it's 1, what is the opposite of 1? 0. For the logic gates. Okay, 1 and 0 we are using, or true false. You can say true false. So if it's false for A, then it's going to be true for output. Okay, Adyan, go ahead.
What makes NOT gate different from the others? I mean, like, there's
NOT
no
gate,
B, only
yeah,
A.
Yeah, it has just one input. It has only one input, NOT gate. That is the only difference between NOT gate and the other ones. Okay, NOT gate only has one input, but the other gates, they have all two inputs. That's why we can say there are two current flows over there. But for NOT gate, there is only one way of current flow. Okay, due to its shape, it has one input and one output. NOT gate is different than the others. Okay.
Okay.
All right, let's continue. Now let's go to the NAND gate. NAND gate basically is a combination of the AND gate, you can see. Okay, it's combination. Whatever we see in the AND gate, it's going to be opposite of it. Remember, in the AND gate, when it's 1, 1, both input, we had the input 1 only. But here, for the NAND gate, it's going to be vice versa of the AND gate. It looks like a D, but there is a hole at the end of it for the NAND gate. Do not confuse with the AND gate, okay? When you see this hole, that means it's a NAND gate. It has two, again, input, one output, one output. So one input is 0, 0 even, we are going to see an output voltage over here, output current. Okay, there is going to be output current. One of the statements is correct even, we are still going to have an output current, like when there is in the B over here. So there is going to be current flow in output. If there is only in A, again, we are going to have current flow in A. But if both of them has the current, like both of them, there is current flow in A and B, then we are not going to observe any current flow in the output. The current will directly go to the like ground. Okay, so current will not be flowing through the output if both of them have the current. Okay. So NAND gate and AND gate are totally opposite. Don't forget that. Like if you know one of them, you can compare the other one. Okay. So the last gate we are going to learn about it, it's going to be NOR gate. From the name, you can remember NOR gate. NOR gate means like it comes from OR, but it's going to be opposite of the OR. Okay. There is only one statement where we are going to observe like a output current, which when there is no current flows in A and B. If there is no current flow in A and B, we are going to still have a current flow in the output X. Okay. If there is current flow even in one of the part, even A or B, we are not going to have any current. It is opposite of the OR gate. Okay. Remember the OR gate. OR gate, if it's 0, 0, the output will be 0. But when there is one input, like current, then there will be output current for the OR gate. NOR gate and OR gate are totally opposite to each other. And AND gate and NAND gate are totally opposite to each other. Yes, Adyan, go ahead.
I mean, are these principles, how can we have electron flow when we don't have any inputs?
Yeah,
electrons?
in the circuits, there are electrons, okay? There are free electrons in the circuits. So even though there is no electron current in the output gate, still there is inside of the circuit, there is electron current, okay? So in the gate, yeah, the current are not flowing through the gates, but the output part is going to be another place. So still there are electrons in the output part. So that's why they are going to flow it. So think about it. You said my name is Isa and I wear black hat. Both statements are correct, but in the output, it is not going to accept this. It is going to say no. Your name is not Isa. You don't wear a black hat. Okay. So it's going to be false statement, for example. Okay. Or you say two lies together, and at the end, it accepts your lies. It accepts it as a true. Okay. So still there are electrons inside of the circuit, but they are not passing through the gates. They are just electrons in the output part. Okay. So this is the NOR gate. NOR gate and OR gate are totally opposite. AND gate and NAND gate are totally opposite to each other. So this part, let me see if there is anything else. Okay. What about combination of logic gates? We can combine the logic gates. Okay. More than one logic gate can be combined and increase the range of the control task that can be relating to perform, like relating to control and alarms. We use the logic gates generally in alarm systems, like at home for the security systems. For example, if there is if something happens at your house, let's say if alarm goes on, that means the input and output are going to be one and one. Okay, input is going to warn the output and it's going to turn on the alarms. Okay, so for the security system, we use this kind of gate. So this was the end of the unit. Let me just go to the question. I have a question for you guys. So there is a combination of circuit over here. First, let's just name the these gates. What do you guys are you guys going to tell me, like, which gates are this? Like, for example, AB gates. What is this? It's AB. Can you tell me what is this AB? It is OR NOT and which gate is this? It looks like a spaceship. It is an OR gate. Okay, this is an OR gate. Okay, when there is when there is one input, remember this is going to be NOT gate. And when there is a letter D over here, this is going to be AND. Okay, so let's check out our box over here and let's find the output current, output output voltage or current over here. It is going to be true or false. So for the OR gate, when it is 0 0, what's going to happen for the OR gate? When it's 0 0, here is going to be 0 2. Okay, so this terminal will be 0. So the first terminal of the X is going to be first terminal of the AND gate is going to be 0. So we are going to put a 0 over here. Okay, and then for C, for NOT gate, if it's 0, then here is going to be 1, right? So we have 0 1 over here, 0 1 for the AND gate. When it's 0 1 for AND gate, what is going to be output? Can you tell me? It is going to be 0. AND gate is always 0 except there is 1 1. Okay, if there is 1 1, then AND gate will be the output for the AND gate will be 1. So if there is 1 0 0 1 0 0, then AND gate will be 0. Okay. Yeah. So then let's move on to the second one. It says AB is 0. AB is 0. Okay, AB is 0. Again, for the OR gate, it's going to be again 0 over here. And for the C, NOT gate is 0. And NOT gate is 1. So NOT gate is 1. Then output of the NOT gate is going to be 0. So both of them are 0 again for the X. If both of them are 0, what's going to happen? Again, X is going to be, output is going to be for the AND gate 0. Okay, let's go to the third one. A is 0, B is 1. When you see one of them is 1 even for the OR gate, the output will be 1. Okay, the output will be 1. Remember, for the OR gate, if one of them is true, then statement will be true. So it's going to be 1. Here we have one input of the AND gate 1. The second one, when C is 0, right? Then output will be for the NOT gate is going to be 1. So now we have 1 1 for AND gate. If you have 1 1 input for AND gate, output will be for the AND gate 1 as well. Okay. Okay. So let's continue. Let's do one more and then we can finish it because I don't want to go further. You guys, I think you guys understand it properly now. So let's do it one more. So let's say A is 0, B is 1 again. So again, output will be 1, right? Since it's the OR gate, output will be 1. and then C is 1, then output of the NOT gate is going to be 0, right? So we have 1 0
Yes.
for the AND gate. 1 0 means 0 already, okay? Since both statements are not correct, so the output will be 0 over here, okay?